Good morning. Today we are going to talk about Fraunhofer diffraction at chemistry. Yesterday we already studied the Fraunhofer single slit diffraction. So here we have a surface which has double slits. A plane wave incident on the surface of xy. We know that height is principle now. So what is height is principle? Each point of incident wavefront acts as a source of secondary wavefront. So here the wavefront which are in the direction of the incident wavefront will focus at a point P and produce a center bright image. And the wavefronts which are refracted at an angle theta will focus at Q. Okay. And the width of slit is represented as A, and the upper position is B. Okay. And double slit diffraction is analyzed by the combination of interference and diffraction. So, how the diffraction and interference occur. The interference occur due to the two slits and two slits that is AB and C, and the diffraction occur due to the individual slits. Interference occur due to double slits and diffraction occur due to single slits. That is in each individual slits. Okay. And we are also known that it is analyzed by interference and diffraction. It is a combination of interference and diffraction. So here is two patterns. That is, one is diffraction pattern and the other is interference pattern. So we are going to find the path difference, maximum and minimum. Okay. We are talking about diffraction. Diffraction pattern is due to each single slit. So, due to each single slit. And next is path difference. So, we know what is the path difference. Studied yesterday. So that is D sin theta. Here D is the width of slit. Here the width of slit is A. So we can rewrite it as A sin theta. And the condition for maximum, that is maximum is A sin theta equal to the integral multiple of wavelength lambda. We can take it as m lambda. And so the maximum we can take A sin theta equal to the whole multiple of lambda by 2. So, 2n plus 1. Lambda bit. Okay. And next we are moving to interference pattern. So the interference pattern is due to double slits. Next we have to find the path difference. So we are considering a right angle triangle here. Here we do a normal. We are taking the top position of the slit AB and the top position of the slit CD. So we got a triangle here. So we are considering this triangle. So the CE is the path difference. So we want to find CN here. So we are taking sin theta. So how we can find sin theta here? Sin theta is opposite by hypotenuse. Here opposite side is CN and hypotenuse is AC. So sin theta is equal to CN by AC. So you can see that AC is A and B. So sin theta is equal to CN by A plus B. We want to find CN. So CN is equal to A plus B sin theta. Okay. So the path difference is A plus B sin theta. Okay. Next is find the condition for maxima and minimum. So the condition for maximum is path difference must be the integral multiple of the variable. So the path difference is A plus B sin theta. The integral multiple of wave length. Next is minima. Minima is path difference is equal to the odd multiple of lambda by 2. So it will be A plus B sin theta is equal to 2n plus 1 lambda by 2. Okay. So here we will find out that diffraction pattern, path difference, condition for minima and maxima, and interference pattern, minima, maxima and path. So the final diffraction pattern on the screen will be the diffraction pattern due to single slit and interference pattern due to two slits. So the intensity will be the square of the resultant amplitude, and it can be written as resultant intensity. you already know this term. A square sin square alpha by alpha square. This term. So this term is the intensity due to single slit. We already studied yesterday. So what is the term? Here is one more term. That is A cos beta. So cos square. A cos square beta. And how it came? So it is due to interference pattern. You already know the diffraction pattern. We can analyze by diffraction pattern and interference. So the A cos square beta is from interference pattern. So intensity square of the amplitude. So intensity at a point Q, that is this point Q is the square of the total amplitude. That is the superposition of the amplitude of diffraction due to each slit. So we can consider the amplitude from the first slit. First slit is a vector R, and the diffraction from the second slit can be that in the opposite side. So also R. Then next we have to find the resultant amplitude. So we are considering a parallelogram. So if or a parallelogram, if A and B are the sides of a parallelogram, the resultant vector square is A square plus B square. We can take it as C, resultant vector. So A square plus B square plus 2AB cos into the angle between the two vectors. It takes as 5. So it's cos. Then here 6 R dash, and A square is R square. R square plus, and B is also R square. R square plus 2 R into R cos 5. So R square plus R square, 2 R square plus 2 into R square, 2 R square cos 5. We can take 2 R square out. So 2 R square is 2 R square 1 plus cos 5. 2 R square 1 plus cos 5 we can take as 2 cos square 5 by 2. So into 2 cos square 5 by 2. It will become 4 R square cos square 5 by 2. Okay. Here R square is A square sin square alpha by alpha square. We can get this equation. Here 5 by 2 we can take it as eta. So the equation will be 4 A square sin square alpha by alpha square cos square beta. And the phase difference phi we can calculate by 1 by 2, 2 pi by lambda into path difference. So phi we can calculate by 1 by 2, 2 pi by lambda into path difference. So we are taking interference method. So the path difference will be a plus b sin it. So phi is 1 by 2, 2 pi by lambda a plus b sin it. So 20 will be cancelled. Here we are taking phi as theta, right? So theta is equal to phi into a plus b sin theta, right? And we already know alpha. Alpha is phi a sin theta by conditions for maximum and minimum due to double slit diffraction. So we know the intensity expression is of a square sin square alpha by alpha square cos square theta. Here sin square alpha by alpha square is due to the intensity expression of single slit diffraction. So now we are discussing about the effect of intensity on cos square theta. So for maximum cos square theta should be 1. So if beta is equal to 0 plus or minus 5 or plus or minus 2 by lambda, the cos theta is 1. We know beta is equal to pi a plus b sin theta by lambda. So we substitute this. Here it is n pi. Beta should be n pi, then only the condition will satisfy. So here pi and pi we can find. So a plus b sin theta is equal to n. This is the intensity maximum. Condition for intensity maximum. Now where is this number? Intensity minimum. So cos square minimum. Cos theta should be 0. So when beta is equal to plus or minus 2 and plus 1 by 2. Beta is equal to 2m plus 1 by 2. Cos beta equal to 0. Now substitute pi a plus b sin theta by lambda equal to 2m plus 1 by 2. So a by cancel. A plus b sin theta equal to 2m plus 1 lambda by 2. This is the condition for intensity. So here there are two graphs. This is the intensity distribution due to the factor a square sin square alpha by alpha. That is diffraction method, and the next one is intensity distribution due to the factor cos square beta. And the resultant intensity graph will be like this. Here the white portion is the diffraction due to single slit, and this one is the interference pattern. The position of certain interference maxima and correspond to diffraction minima at the same position on the screen. As a result, the interference pattern will be missing in this direction of theta. So, some values of theta, interference maximum is n plus b sin theta m lambda, and some diffraction minimum. Equation 1 divided by 2 will become a plus b sin theta m lambda by a sin theta. So lambda and lambda cancel, sin theta. So a plus b by a is equal to here m is the missing orders, so n into a plus b by a into m. This is the equation for finding missing orders. Here a is the width of the slit and b is the opaque position and is the missing orders. n is 1, 2 like that. So there is a question. Reduce the missing orders for a double slit of Fraunhofer diffraction if the slit width is 0.16 millimeter and there are 0.8 millimeter apart. So here the width of the slit is 0.16 millimeter, that is 0.016 millimeter, and B is 0.8 millimeter, 0.08. So the equation for missing orders is n into a plus b by a is equal to n. So n is we can find n by n. So substitute these values in this equation. So n by n is 0.016 plus 0.08 by 0.06. N by n is equal to 6. So we will find the m. So n is equal to 6n. Put values 1, 2, 3, etc. for n. Then it will become n. N is equal to 6. If we put 1 on n, it will become 6. If we put 2, n is equal to 2, it will become 12. If we put 3, it will become 8. So the missing orders will be